All right, so we're in 2.6 and it's called compounding the problem. Compounding is a word that I don't know, maybe you have and have not heard of it, but this word compounding means like you're doing a calculation on it, but the reference goes like this, right? You're calculating something and then you're calculating it again. But the first time you calculated it is now being taken into account the second time you calculated it. So pretty common is money, pretty common is like growth of bacteria or decay of something. So what they're saying is like when you put money in an account and they compounded it, they're saying it's going to calculate some type of thing, right? And then when it calculates again, either the second month or the second year or whatever, what's being calculated is included in the first amount of interest that you earn that first year or first month or first whatever. So that's why they say, like, in terms of the land of investing, time is your friend. Okay. So this is what we will be doing today. Understand how different factors affect amounts earned from compounding interest. Determine the features of a new function. So this is our new function. This guy is E. He's not a variable, he's a number. I'm going to introduce you to him today. Which factor makes the most difference in the amount of money earned in a savings account? Is it the interest rate? Dun, dun, dun. Is it the number of compounding periods per year? Dun, dun, dun. Or is it the number of years invested? And this is very important because y'all are young, right? And so you have your kind of like your whole life to invest in front of you. So that this is going to help you, make money on the stock market. If you've ever heard people making money, they know which one of these makes the most difference. Okay, let me scooch this over a little bit so I have more room to write up here. Okay, so moving on. So here we're going to talk about you making money. So as an enterprising young mathematician, you know that your superior knowledge of math will help you make better decisions about all kinds of things in your life. One important area is money. So you've been contemplating the world and wondering how you can maximize the money that you could make in your savings account. Okay. If this is all new to you and you haven't learned how to save money, I would learn how to do that sooner rather than later. Okay, you're young and you haven't saved much money yet, but as a matter of fact, you have $100, but you really want to make the best of it. You like the idea of compound interest, meaning that the bank pays you interest on the money in your savings account, including what interest they had previously paid. This sounds like a very good deal. You even remember that the formula for compound interest is exponential. That's why they say things like, oh my gosh, it's growing exponentially, right? This idea. So here's the equation where here they tell you what everything is. A is the amount of money after time. P is the principal, not like the principal of your school, but the principal, like their starting base money. So in this case, your $100 would be our principal, how much money you have or how much money you're borrowing. Okay. And the original amount on the annual interest rate is R. So he goes here. Notice it's 1 plus. Remember, we talked about this in our last little problem. Divided by N, meaning the number of compound periods per year. So they'll tell you monthly, yearly, quarterly, whatever the period is, right? So just so that we are all on the same page, quarterly means a fourth. So it's 4 times per year. And the number of years that you plan on leaving this in there, okay? So you're young, let's say that you leave it in there until you're like 50 and you're like, Ms. Johnson, 50 feels so far away. Okay, but just pay attention to that and let's see what happens, okay? All right, so it says, if your savings account pays a generous 5% per year, and you say, Ms. Johnson, 5% doesn't seem very much. Actually, for a savings account, that's a lot. My savings account currently is like 0.3%, not 3%, 0.3. So it's like a sad little penny every time. Okay, so 5% per year and is compounded only once each year. How much money would be in the account after year 1? How much money would be in the account after 20 years? Okay, so I need to use this equation to do this. Okay, so I'm gonna take this equation and I'm gonna plug all my stuff into it. all this stuff that they told me. All right. So pick a number and tell me what variable it should go in for. So if your savings account pays you a generous of 5% per year and is compounded once a year, how much money would be in the account after 1 year? So pick a number, pick a variable, and tell me which is what. 100 is P, someone says. Do you guys all agree? Is 100 P? Everyone says, yes, Ms. Johnson, you just told us that. Very good. So here's what I like to do whenever I have an equation. I copy it. So I go A equals P parentheses 1 plus R over N to the NT. Okay. So the very first thing is I copy that equation and there it is. And then I start plugging things in directly beneath so I remember what it is. Or I would also like go over here and write stuff in. So someone said $100 is P. So I'm going to be like, this is my P. Very good. Someone else said, hey, Ms. Johnson, N equals 1. Very good. So this little guy, N equals 1, is the number of compounding periods each year. This said, compounded once each year. So therefore that's 1. So then this guy goes here once. This is my N. And then, oh, I should use different colors, Miss Johnson. Use different colors so it stands out. This is N. Let me change this for this. This is P. Someone else says 5%. Uh-oh, we have, yes, 5% is 0.05. So here, this is my R. This is R. Okay. And written as a decimal is 0.05. If you remember, right, it's 100%. So we divide that number by 100. That's why it's 5.05. Someone else says, Ms. Johnson, T equals to 1. T equals to 1. And is there any other one? A is what I'm looking for. P, you told me 1 is 1. R is 0.05. N is 1. N is 1. And T is 1. Oh, that's it. So now I just plug everything in there. Yeah. Okay. So let me plug in. So this is 100. And then that's 1 plus, and then this is 0.05. And then N is 1. What's that color? Sorry, I'm trying to choose the same colors. And then this is 1, and then T is 1. T is that green color times 1. Okay. And then I'm going to keep everything else the same exact color. Right? Okay. So then that's it. Yes, that's it. So then I'm going to take my handy dandy calculator. It's right here. I put it right here for you. And then I'm going to plug all that in there. Okay, so I go 100 parentheses 1 plus 0.05 divided by 1, and then close parentheses to the, and then 1 times, oops, my times needs to stay up there. So I'm going to put parentheses 1 times 1, and that's what I get. It's $105. Ms. Johnson, do I have to plug in those ones? Because 0.05 divided by, yes. You do not have to plug it in. If you already know how to do this, then great, do that. But I am literally showing you, I'm plugging exactly the same thing in here. Okay. Now, before I think it was in your Ready, Set, Go for, I forgot which one, maybe 1.5, it gave you these problems and then the student was plugging it in wrong and he wasn't including this one. Okay, so if you don't include this one, you literally get 100. Oh, let me just copy this. Copy this here. And then let me get rid of this one really quick. Okay, so if you look at this, right, compare these two. So let's say you put in $100 and at the end of the year, this is your balance. You're like, oh, cool. My money's just sitting there, made $5. Good job, money, right? But over here, you put in $100. And then at the end of the year, you see your balance is $5. What would you say? What would you say to that? What'd you say? You'd be like, cool, no problem. Yeah, high five. Is that what you would do? Yes, exactly. Someone done robbed me. I don't know why I have like a southern an accent from like the old westerns, but apparently that's when people rob me, that's what I say. Someone done robbed me. Someone done robbed me. I only have $5. I'd be on the phone in a minute talking to the bank, talking to the manager, talking, no, you're not helping me. I had $100 in there. Why is there only $5? So this actually legitimately happened in my very first teaching job. And this is way back in the day. Like you couldn't even look up stuff online because like online banking didn't really exist. I'm old, y'all. Okay, so then I called in and they told me that my balance was like negative $600. I was like, what the heck? And then I do listen to the last like 5 transactions and it said like check number 672 for $900. And I was like, what? I didn't write no $900 check. And then check number 672 was sitting in my checkbook, which is funny because I don't even know if you guys know what a checkbook is. But moving on, Ms. Johnson, any questions on this part here? Yeah. Okay, so very good. Yeah, the reason why banks sometimes give you interest is because they literally use your money to make more money, right? They lend it out, they invest in other things, they give, small business loans, they give loans to people, they let people use it on their credit card. So yeah, the 100 actually came all the way from up here, right? Okay, very good. All right, so I'm going to pause this problem. I'm going to pause the video rather, and I want you to figure out, okay, this is the same problem, same context. How much money would be there after 20 years? So I want you to plug, now, no, look, don't just plug it into your calculator. I need the actual equation. So I want the equation first. So go ahead and do that and pause. All right, so for number 2, it says how much money would be in the account at the end of year 20? Okay, so again, I'm using the same exact equation. I'm using the same exact equation here, right? So I'm going to plug this in over here, right? So we got, and then if you can you start putting in the chat what number goes where? What number are we looking for? Right. So some of you already have this. Very good. All right, very good. So some people already have this done. So I'm just gonna snip this because it makes my life a little easier. Where is it? Here it is. So this is what one of your classmates says. She says 100, 100, 1, 1 plus 0.05 divided by 1 to the 1/20th. Perfect. So in reality, I can just take that same equation here, copy it. Ignore this guy, the second guy. Right? So the 100's the same, the 1's the same, the 0.05 is the same, the 1's the same, the 1's the same, and it's just this last one right here. It's just a 20. Very good. 20 goes in that T spot, Miss Johnson. Very good. So there's my answer, $265.33. Now, some people are going to cut it off and some people are going to round. Both are actually correct. So it just actually depends on your bank. So it's so there's your answer. It's about $265.33, right? So very good. Any questions on this? Very good.